Hello, welcome in another important video. I hope you all are doing great. From previous video, we have started installing all the dependencies that we require to create decentralized applications, right? We have installed Node.js, we have installed Solidity, then we have installed Ganache, Truffle, and VS Code. So some of these software such as Node.js, VS Code, and Solidity are known to us, but these two softwares, which is Ganache and Truffle, is something new. So let's try to understand importance of Ganache and Truffle in creating decentralized applications. So let's start with Truffle first. So Truffle is not a software, it's just a tool that helps us creating decentralized application. So the first feature that Truffle provides us is a development environment. Well, in order to create a decentralized application, we will require Solidity setup, we will require test cases, we will require Web3. With combination of all these technologies, we will be able to create complete end-to-end decentralized applications. So Truffle basically takes care of providing all these dependency ready for us so that we don't need to spend our time on setting up everything manually, right? So since Truffle is just a tool, we can install that Truffle tool using npm command. So we will install this Truffle globally. We can start using this Truffle from our command line. Then Truffle also provides testing environment, and not just that, if you follow this link, you will be able to see all the features that Truffle provides at the moment. So the first feature that Truffle provides is built-in smart contract compilation. So it means we will write Solidity smart contracts, and in order to compile that contracts locally, this Truffle will provide us environment, and we can even test our compiled contracts. Then we have other features such as linking, deployment, and binary management. We'll see how easy it is to deploy our Solidity smart contracts on a local blockchain further in a video, but for now let's just move on with other features. So second feature that Truffle provide is automated contract testing and rapid development. So while creating Solidity smart contracts, we often require to make changes in Solidity smart contracts, but while doing the changes, some of the features might break. So in that case, we will require some testing environment which will help us understanding what's wrong in our code, right? So Truffle inbuilt provides us testing environment. And while developing smart contracts, we will often require to communicate with our smart contracts. So we've used Remix IDE. Remix IDE provides some default user interface to interact with smart contracts. But since we are developing everything on our local machine, we don't have that facility at the moment. But using Truffle console, we can communicate with our smart contracts easily. Also, we can easily configure our public private networks using Truffle. So I think that's enough for the introduction. In order to use Truffle, all we need to do is we need to select this Truffle, and then inside of this Truffle we will see overview, then Truffle quick start, right? Let's click on this getting started, and you'll be able to see this installation of Truffle. So you just have to copy this command, and let's go inside of any terminal and just start installation. So if you might have observed, we are trying to install this globally because we want to use Truffle on our command line. Well, this is already installed in my machine. I'm not going to install this again. Let's move on to the next step, and next step is creating our Truffle project. So you have two choices. Either we can import already created project, and there is a library that holds some default projects in Truffle. But for the sake of simplicity, we are not going to use already created project because it will be a little bit complicated for us. We will start from scratch. So here I have created one auction folder, and inside of it, let's open command line, and here we will write one command. Let's give it a name, Truffle init, and this command will basically initialize all the dependencies, all the files, and all that stuff that is required to create any Solidity smart contract. So if you can see here, we have got 3 folders, and there is a Truffle config file, right? So let's try to open this in VS Code and understand more about the file structure. All right, so as you can see, we have got 3 folders. So this is the contract folder, and we are going to mainly deal with this contract folder itself. So this contract folder basically holds Solidity smart contracts. So if you can see here, so they have provided some basic smart contracts, and then after that there is a migration file. So now this migration file basically helps us integrating our this migration file basically helps us migrating our created contract on any blockchain, right? And you will be able to see there is a test folder. So this test folder basically hold all the files, all the test cases that we will write while creating our Solidity smart contract, so that we can easily debug errors inside of the contract, right? Then there is a Truffle config file. So this is the important file. This file basically holds all the network related information. So if we want to deploy our smart contract on local blockchain, so we will take help of this network file, and we will configure server details here, and then we will be able to deploy our contracts on the local environments. So if you can see here, there is some commented code, and whenever we will deploy our contract, we will simply uncomment this code. So for now, let's just create a separate contract. So let me give it a name, hello world. So let's try to create some basic Solidity smart contract. But for now, if you can see, if I write pragma solidity 0.9.0, but if you can see here, there is no highlights for this syntax. This condition will be the same in your case also, because by default VS Code doesn't provide syntaxing for Solidity. So in order to make this syntax highlights properly, we'll have to install some library. Let's simply go inside the marketplace and search for Solidity. So here we have this Solidity package which has 600k downloads. Let's try to install this. Alright, so after we're done with the installation of this extension, you will be able to see that your syntax is now highlighted, right? So now let's move further and try to create basic Solidity smart contract. So in our case, we are going to create hello world contract, and that's pretty much it. So I'm going to go and create one function here, and let's give it a name, get message, right? And this function will be public. So basically I just want to print some message as soon as someone call this function, right? So let's call this public. Okay, my bad. Okay, and this function will be pure. Reason being, we are not changing anything inside, we are not changing any state inside of this function, and also we are not returning any state from our function, so we can keep our function as a pure function, right? And then it will return string value, and the location will be memory. So let's quickly return some message. Now if I save this, our contract is done, right? Okay, so now in order to compile this contract, let's go back inside the documentation and see how the contract compilation command works. And you have to click on Truffle quick start. They have created one folder locally, and inside of that folder they have used this command to fetch already created project in the Truffle environment. So in our case, we've used command truffle init, so we don't have to repeat these steps again, right? Let's scroll it a little bit down, and this is about testing, and here is the compilation. Okay, so in order to compile our created smart contracts, we have to use this command truffle compile, but before that we have to write one migration file. Now this migration file will basically help us interacting with the Solidity files from our console. We'll see more about this in a while, but for now let's just create one migration file, right? So our migration file name will be hello world, and its extension will be JS. Now the reason why I've used _hello world is because this sequence is important when you are compiling your smart contracts. So this is nothing but a sequence in which you want to compile your smart contracts. Let's say you have dependency on initial migration, and let's say you have dependency on the initial migration before the hello world contract gets compiled. So you have to compile this, you have to make sure that this initial migration file will get compiled first, and then the hello world will get compiled later on. Okay, so this sequence will be really important, especially if you are designing, if you are creating huge project. So in that case, you will be having multiple Solidity files interdependent on each other. So you have to make sure that every single dependent file will get compiled first, then your actual contract will get compiled, right? So this is the basic syntax. You can read more about this in the documentation, but for now we don't have any dependency on any one of these contracts. Both the contracts are independent, so we don't have to worry about this, right? But just to make this object of hello world available to access, we have to make a copy of this initial migration file. So let's go ahead and copy it and paste it here. The only thing that we need to change is the name of our contract, right? So let's paste hello world here. Let's change this hello world object, and that's all we need to do here, right? Alright, so our migration file is also done, and if you go here inside the build folder, you will be able to see there is nothing at the moment. You can see there is nothing at the moment. Okay, but as soon as we will compile this Solidity smart contracts one JSON file, as we already saw in remix IDE also, we will get two important things. One is your abstract binary interface, and then you will get your opcode. Okay, let's try to compile these two contracts. So I'm going to use external terminal, and in here I will use command suggested by our documentation. So I'm going to copy this and let's paste it here. So let's wait for a while. As you can see, we have received one warning. Well, this is not an error, so we don't need to worry about this. But if you want to remove this SPDX license warning, all you need to do is just go back inside of our hello world contract and copy the first commented line and paste it inside of our contract, right? Okay, so this commented code will remove the warning that we are getting in our console. Okay, for now we will just move ahead with the warning because it will not be the hurdle for our further process, right? Okay, so our code is compiled successfully. Now if I go back here and see inside the builds folder, you will be able to see there are two JSON files. So if I go inside the hello world JSON file, so here is all the abstract binary interface that we required for interacting with functions inside of smart contracts, right? So it is basically holding the name of the function, the type of the function. Also, if you have state variables, it will give information about that as well, right? And the next thing that we need, and the next important thing is your bytecode and opcode. So this is also required for Ethereum virtual machine to interact with smart contracts, right? So whenever you will compile your code, these two files will automatically get generated from Truffle, right? Okay, so now let's move ahead and deploy these created contracts on Ethereum or local Ethereum virtual machine. So in order to do that, we have to open installed software, which is nothing but Ganache. Okay, so this is how the Ganache looks like. We don't need to create any workspace for now. Let's click on this quick start, and it will basically give us an interface which will give information about our local Ethereum blockchain, right? Alright, so just to understand more on this, let's understand the entire process. So we have done with creating our smart contracts. We will test it soon, and we want to migrate our created local contract into the blockchain, right? So in order to migrate these created contracts, we have three options. Either we can deploy it on our local Ethereum blockchain. We will see how to do it in a moment. Another way is we can we can deploy our smart contract on the test network, which we will get from third-party external services, chill contract, and we can deploy our contract on actual Ethereum blockchain. So we have these three options, and the most recommended way, especially if you are creating smart contracts, is deploying your contract on local Ethereum blockchain. So that is the reason why we are using Ganache. So Ganache is basically creating an environment where we can interact with our blockchain, and it gives us different addresses to interact with the blockchain. Each of this account will have 100 Ethereums, and this is just for our local testing, and in actual main network it doesn't value anything. Then if I open this new tab, it will give me information about, it will give us information about multiple blocks which will get added as soon as we interact with our smart contracts. And then there is a transaction tab, contracts, events, logs, right? So all in all, we can say it gives an entire information about the blockchain that is running in our local machine, right? We will see more about Ganache in a separate video, but for now, let's just continue with the deployment, right? So in order to deploy our created contracts, all we need to do is we need to write one command, truffle migrate. Now this migration command will work only when we have local environment set up. Okay, only when we have correctly set up our addresses. Okay, so we forgot to do that, so we'll go back in the truffle config.js file, and in here make sure that your deployment is uncommented. Earlier it will be like this. Inside the truffle.config.js we have to uncomment this development, right? And make sure that your port number is exactly same as we get to see here, right? So it is 7545, so you have to change if it is not same in here, right? So once you do that, now we can use migration command. Now this truffle migrate command will start migrating our Solidity smart contracts on the local Ethereum blockchain. We can see those changes in the blocks tab of our Ganache. So as soon as our command will progress further, we'll be able to see some changes inside of our Ganache. So let's wait for a while. So as you can see here, new blocks is getting added. Now we can say our Solidity smart contracts is deployed on a local network, right? So if you want to see more information about each of these block, you can just click on any one of this block, and here you can see gas used, gas limit, then the date when this transaction happened, and all other information related to the transaction, right? So here you will get to see from address, which is nothing but the address of previous block, and to contract address, that is nothing but address of this current block, right? So our contract is deployed on our local Ethereum virtual machine, so we can start interacting with it. So in order to interact with it, just have to write one command, truffle compile. And in case if you have any confusion about the commands, you can just go inside the documentation, and inside the getting started tab itself, you just have to scroll it a little bit down, and you will get all these commands here, right? So for now, we just want to interact with our smart contracts. So let's copy this truffle develop command. All right, you have two options. Either you can use truffle develop, or you can use truffle console. So among this, we are going to use truffle console, and let's hit enter. Okay, so now you can see we got a development environment. Let me zoom it for you. Okay, so our development environment started. That means we can start interacting with our smart contracts. So earlier we were interacting with smart contracts using Remix IDE. So Remix IDE by default provides some user interface to interact with smart contracts, but since we are using local environment, there is no such facility, so we have to take help of consoles to interact with smart contracts. All right, so let me scroll it a little bit down and see how to interact with smart contracts. So here you can see there is one example. So we need to create an instance of our smart contract. So in order to create an instance, let's use instance is equal to a wait and the name of our smart contract. So you can see that contract name in the compiled code, or else you can go inside the code and copy your contract name. So this contract name will come from your artifact. So let's copy this name and just go below, paste it here, and simply use deployed. This will create an instance that is nothing but an object that is pointing to this contract. So now if I use instance dot methods, my bad, okay, so you can use instance dot methods. We got the list of the functions, right? So let's try to access this. So I will use instance dot get message. So as you can see, we got the message which is inside of our smart contract, right? Okay, all right, with this way we just saw how to create Solidity smart contracts using Truffle, and how to create migration file, then how the compilation works, how to migrate your smart contracts on local Ethereum blockchain, and we saw how to interact with the deployed contracts. Okay, but still this is not the complete project, because there is no user interface and end users cannot interact with our smart contracts for now. So we will need to create some user interface so that user can access that from any website, but we will see that in the next video. For now, I think that's it for this video. Thank you very much for watching. See you in the next video. Bye.